Hey Buffaloes, it's Mr. Glass. We're going to do some backyard chemistry today. Hopefully it'll help you out with your stoichiometry a little bit. We're going to do this very simple household reaction. We're going to take baking soda and vinegar. So you guys can totally do this on your own if you want. And at home, as long as you're wearing your safety glasses. Make sure, because safety is #1 priority, right? Okay, so here we go. We're going to take a look at how much carbon dioxide is released from the reaction of baking soda and vinegar. Now to do that, I've already poured some vinegar in this test tube right here. We're going to pour some baking soda in here and get the actual mass for it. So I'm going to set a beaker here so it'll hold the test tube. I'm going to turn my scale on and hit tare so that we can weigh this test tube in hopes of getting the mass of baking soda. So I don't know if you guys can see that or not. It is 18.98 grams. So my test tube, I'm going to write that down here, the test tube is 18 point, I think it's 99. It's saying 99 right now, so we're going to go with it, 18.99 grams. Now, I'm going to take some baking soda right here, just a smidgen. I don't want to use too much. Okay, because that'll go all over and then I'd have a mess. I know you're all rooting for that, but whatever. Okay, we're gonna put this on here. Now I know the weight of the test tube, right? Okay, but my mass is now 19.77. So with baking soda, it is 19.77 grams. Now, that gives me a total in the test tube for the baking soda. So my baking soda is the 19.77 minus the 18.99, which is very clearly 0.78 grams. Okay, that should be perfect. Let's hope anyway. Okay, now I'm going to pour some vinegar into the beaker. Vinegar into the beaker. Okay. Now there's a bunch of mass here, but this is not what I'm worried about. Okay. I'm actually going to hit tare on this. And so it'll zero out. The scale says 0 right now. Now I know there's 0.79 grams of baking soda in this test tube. So when I put it in here, this should say 0.79. Okay. So let's do that. Here we go. Baking soda and vinegar in 3, 2, 1. Safety. Oh, hey, it's not going to go anywhere because I've already did this before. Oh, it's not going to go over, right? Okay, we're good. Whew, scaring me for a little bit. Look at the bubbles. Yep, my daughter just learned how to say bubbles. It's really fun. So anyway, so the scale should read 0.799 right, or 0.79 right now, but what? If I don't touch it, it's down to 0.48, 0.46. It keeps going down. What's going on? Oh, hey, maybe there's a chemical reaction happening. Okay, so it looks like it's going to settle at, oh, no. It's going to settle at 0.40. We're going to see, I'll take a look at it, see if it went down again. We're not done yet. Oh, there's still bubbles coming out. You see that? Okay, still bubbles, so it's still losing mass. What is leaving? Well, it's the carbon dioxide from the reaction. Remember the reaction? You take baking soda, you add vinegar, you get the sodium acetate, which is still in there, mix some water, but the CO2, which is a gas, leaves the beaker. It's gone. So we're down to 0.38. That's what we're going to go with. Okay? So it went down to 0.38. Okay, now remember the baking soda reacted, and that's how much is left over. So let's see if that's about right. Okay, that's a loss of 0.40 grams. Okay, let's see if that checks out with the actual chemistry or the calculations that happen here. Okay, we started with 0.78 grams of baking soda, which is NaHCO3. Okay? Now, if I'm going to go through and I'm going to say, hey, how much CO2 is released, I'm going to go to grams of CO2, just like we did for our notes from earlier this week. So what I'm going to do is I'm going to set a little fence post here. Okay? And the first step's always the same. I use the molar mass of the known. Okay, so I use the molar mass of this baking soda stuff. So on the bottom, I'm going to have grams of baking soda. Okay, and on the top, I'm going to put 1 mole of baking soda. During this step, you always use 1. It doesn't matter whether there's a 2 or 3 in the equation or whatnot. You always use 1 here because it's comparing it to grams. So I'm going to add up sodium plus hydrogen plus carbon plus oxygen 3 times, which is 84 grams. 84 grams per mole, right? Okay, that's the first step, step 1. Step 2 is always very similar, okay? Now you see here, grams canceled out. So I want that same thing to happen here. If I have moles of NaHCO3, I want moles of NaHCO3 down here. Okay? Now what I'm going to is I'm going to CO2, because that's in the question, how much CO2 is released. So I'm going to go moles of CO2. Okay, now this is a mole ratio. This is the second step. Mole ratio. Okay? During the mole ratio, you go to the equation and you balance it. And if you look here, I've got 1, 2, 3, 4, 5 hydrogens. 1, 2, 3, 4, 5 hydrogens. Hey, it's actually going to be the same thing. There's 1 sodium on both sides. There's 1, 2, 3 carbons. 1, 2, 3 carbons. And oxygen's the fun one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so it's all balanced. It's actually all 1s here. So luckily we go to the equation here and they're both 1s. That makes the math pretty simple. Okay, so one more step. Step 3 is to take the molar mass of the unknown and use that there. Okay, so we use, let's write an N there because I'm totally on, yeah, whatever. Molar mass unknown, mole ratio, molar mass unknown. So just like the moles here are going to cancel out, we're going to make it so the moles cancel out here. So we're going to put moles of CO2 here and grams of CO2 on top because that's eventually what I want, right? I'm comparing the molar mass of CO2 to the number of moles. This is always 1, even regardless of that being 1. The grams on top for CO2 is add carbon plus 2 oxygens. That is 32 plus 12, which is 44 grams, okay? Now all you need is your handy dandy calculator. You can see that you have 0.78 there. 0.84 is on the bottom, so that'll get divided. We have the times by 1, divide by 1, but so I don't need to do that, but because they're 1s. And then you have the 44 on top, so we're going to multiply by 44. So we're going to go to our calculator. We're going to put in 0.78, divide the 84, times by 1, divide by 1, and times by 44. What comes out is 0.41. Hey, look at that. All right, so my grams of CO2 is 0.41 grams of CO2 is what I should get. Hey, how much did I lose? What? That's almost perfect. Right, we're a little bit off there. It's probably from our measurement. The scale only goes to the final digit, but you can see that I can use stoichiometry to figure out how much I'm going to lose. If I use 0.78 grams of baking soda, I'll lose 0.41 grams of mass, which is exactly what we did, right? Because that 0.41 grams of carbon dioxide lifted off into the air. Okay? So stoichiometry works, and by all means, get help whenever you need it. So I'm going to post this as soon as I can, and you guys can email me any questions you guys have, all right?